Hey, Matthew Swinimer here with Collicutt Energy. What do you think of my new hack job? I call this the COVID cut. Definitely am excited for the barbers to open up and for this all to grow back. But with that being said, I'm excited to get into this topic, which is called power markets. This is the fourth episode in this series called Understanding Power. And today's topic is all about understanding the cost of your utility bills. And the first thing I want to talk to, my screen's here if you're wondering why I'm looking over here. First thing I want to talk to is, why do you pay what you pay for your power? And I've actually brought up my utility bill to actually understand. And you'll see on the screen is that in the month of December, I paid for electricity and for natural gas, I paid $157.90. Now, that seems relatively cost effective for 1 month, but let's actually break down what did I actually pay for. So you'll see in the top right part of the screen that my electricity, I actually paid, I pay 7 cents a kilowatt hour. I use 303 kilowatts and I paid $19.97 for the actual energy. Yet I somehow paid $68 in total for electricity. So what you're seeing there is you're seeing all of the costs associated with transmitting that power from the centralized power generation right through to the final site, which is my house. And so you see on the right there that 29% of my bill is actually the cost of power. 71% of my bill is just the cost of getting power to my house. Let's look at natural gas. Natural gas, I paid $38 in the month of December. It was cold, and I pay a very high rate because I haven't bothered to renegotiate my rate. I'm on a 5-year fixed. I signed this up a long time ago, so I'm paying a very high rate in comparison. But in total, I'm paying $89 a month. You'll see on the right again that 43% of my bill is actually the cost of energy, and then 57% is the cost of the utility. Now, those numbers vary from residential applications to industrial and commercial and high-use customers, but just really wanted to start this video off talking about power. So you'll see right off the bat, there's two major factors or two primary categories. The first is the energy charge, and then there's the cost of the transmission. Sometimes it's called distribution charges or transmission or TND. And so I'll reference both of those. So first of all, let's get into what are we paying for with the energy charge? Well, simply put, we are paying for the cost of energy that is consumed at our facility, at our house, at our industry or industrial application or our whatever that is. And we typically are paying that in dollars or some sort of rate in dollars per kilowatt hour. I pay 7 cents as you saw earlier on. Some people may pay a little bit higher. Some of the major factors that play into the energy charge are the types of generation mechanisms within your jurisdiction. Some are cheaper, some are more expensive. The supply and demand curve. Do we have a lot of supply and not a whole lot of demand? That will bring price down. If it's the opposite, you're going to see prices rise to incentivize power generation increase. Weather, climate, geography, those play a huge role. And then the final one, which is definitely starting to play a much larger role in power costs, is the regulatory policy. And we'll get into a little bit of that later on in this video. Second aspect is the cost of transmission. And what are we paying for there? Well, we're simply put, we're paying for the cost of getting those electrons from the centralized generation facilities right through to our final end use customer location, whether that's your house or again, a large industrial customer. Okay, so let's get into how is power transmitted. Well, first thing you're going to see on the screen is on the left, you've got the centralized generation plants. Most models have existed around this idea of a large centralized power generation facility. And on the right, you have customers at different voltage rates. And the first thing that we're going to do is we are going to step up the voltage coming out of that generation facility. And the reason we do that is so that we can transfer large volumes of electricity at high voltages and at low current so that we're not losing tremendous amount of energy as we go down the lines. There is some loss, but high voltage does allow us to build cheaper power lines because we're not needing as much copper to handle that flow. And the second thing is that we're just going to lose less power. There's less resistance. So then we're going to those high voltage power lines, and sometimes there are customers who draw power from those high voltage transmission lines, but typically these are used to transport from a centralized facility that's way out in the middle of nowhere to large urban environments. And then so what we're going to do is we're going to end up we're going to step down from transmission level voltage down to what's called distribution level voltage, and that voltage can range from as high as 26 kV down to, as you see on the screen, 120. You're going to have probably transformers and substations at different levels to step that down further, but then you've got the distribution level, and this is where most of us customers and most of the load is. It's on the distribution level. Okay, so now what are we paying for when we buy an electron of electricity? Well, the first thing you're going to see on the screen is you're going to see the cost of just simply generating electricity, symbolized in red, and then that is going from the substation to the distribution substation, and we're incurring that transmission charge. And then from the distribution substation to our facility, we are incurring the distribution charge. So the next topic I want to get into is the concept of regulated versus deregulated markets or jurisdictions. So what is a regulated environment? Well, simply put, it's a single entity that owns everything, right from the generation capacity right to the meter on your house or your office space or your building. So typically the utility is the monopoly. You really don't have any choice, and the utility sets the rates. You really have no option. The next is a deregulated energy market, and there's different ranges of deregulation, but typically what's happening here is it's a competitive marketplace where multiple entities can buy and sell power. So on the generation side, you have multiple power generators that are competing to provide power at the cheapest rate, and then on the customer side, you have retailers who are competing for customers by offering the best rates. So what this allows is a customer to have a choice in who they are going to get power from, and that choice can be based on cost. It can be based on sustainability. So it gives the customer the choice, and that's one of the benefits of a deregulated power market. So let's look at a diagram that explains this a little bit better. What are we seeing? So again, right at the top there, you're seeing that from power generation right through from high voltage transmission through to distribution, right down to your meter. It's all done and owned and operated by a single entity. You're seeing that illustrated with that straight line. On the unregulated or deregulated side, you have multiple power generators and you have multiple retailers. That allows you as a customer to have some choice. It allows there to be some competitiveness within the marketplace. Some people think that's a good thing, and sometimes that can also be a bad thing. So one of the last things I want to speak to is the concept of centralized power generation versus distributed power generation versus behind the fence generation. And I think we all understand large centralized power generation, and this has typically been the model for most jurisdictions. We are starting to see a move though to distributed generation, where what we're doing is we're placing generation in spaces and places where there's a local need for generation, and by doing that, by putting distributed generation in these areas, what we're able to do is we're able to reduce the capital required for getting the power from these large centralized facilities into these maybe newly built out urban environments. And the last thing I want to speak to is behind the fence generation, and one of the ways that we can actually reduce our transmission costs, reduce our utility bills, is by actually generating our own power. If you're a large industrial customer, there's huge incentives for you to generate your own power. Well, the first one is that you probably can actually generate power cheaper than the actual energy cost that you're buying power from. And the second thing is then the transmission cost. By generating power, you're not having to pay for all of that transmission up front. So this is a dramatically effective way of reducing your utility bills by generating power behind the fence. And depending on your jurisdiction, there might even be an ability to export that additional power if you oversize your generation facility and actually incur a revenue or generate profit from putting that power onto the grid. On the screen there, here's an example of why some of the behind the fence generation opportunities are so lucrative. Is from other episodes you might have heard us talk about combined heat and power, but if let's say you have an electrical load and you have a heating load, you can actually generate your own power on site creating heat to offset another fuel to provide that heat. So it allows you to achieve fuel efficiencies as high as 93%. That's pretty incredible. So my name is Matthew Swinimer. I'm with Collicutt Energy Services. That has been this topic of power markets. We covered a lot of content there. If you have any questions, you want us to go deeper into a particular topic, feel free to send me a note, send me an email, give me a call. Love to hear from you. Thank you again and have a great day.